Everyone, my name is Jason. I'm a solutions engineer for the Google Cloud team, but I actually won't be talking about Google Cloud today. I'll be going over some considerations and best practices for enterprise app developers. So there's 5 topics that I'll be covering today. Each of these are kind of a review, but I'm going over these in the context of the enterprise app developer. And these are very important things to consider. So Google Play, your app distribution mechanism. Manage configurations, which provide app management and customization through EMMs. Manage profiles, which allow data segregation, separates the work user their data. App auth for single sign-on, and purpose-built solutions. So manage Google Play. You've heard about this yesterday during Fabian's session pretty extensively. It should be, or hopefully it's apparent for the app developers as to why they should care about Google Play. And this is the mechanism that gets your app into the work profile. EMMs are integrated with the Play APIs on their side, so that way as an app developer, you don't have to care about wrapping your app, getting your app onto all the different storefronts that are out there. You just publish to Google Play, and the EMMs do the work on their end and pull your apps through. The other benefit here, of course, is that you can publish apps privately, which is coming, and this helps you avoid, side-loading apps, which could possibly help with, piracy and things like that you mentioned. And you're also using Play for your app updates. Manage configurations. So just a disclaimer, that's not what managed configurations look like, but it was either this or showing you test TPC, which kind of confuses people because the end user doesn't necessarily see what's actually happening on a device with managed configurations. Just to review, this is how you can expose your app's configuration settings, which are read by EMMs and set by IT. This helps you avoid having to create disparate management dashboards and create some more consistent experience for the IT admins who are setting app policies for several apps. It's useful for things such as provisioning. For example, VPN or network server configurations that might have to be manually input by a user can just be preset by the IT admin. The other thing it's useful for is security. So disabling or enabling app features that IT might deem secure or insecure. Good use of that would be maybe like preventing someone from saving to Google Drive or downloading data onto the device. And the other thing that it's useful for, of course, is just general management. Good example of that would be presetting managed bookmarks on a device or for a user. So yesterday, Fred covered how EMMs interact with the Google Play API. An EMM gets the managed configuration schema by using the Play EMM API, and that's provided by the app developer. Here's an example schema for an app that can be remotely configured to be allowed or disallowed to download over the cellular network. This is what the restriction element looks like. Note that the title and description are drawn from a localized resource file. And app developers will want to be very descriptive for the title and very clear in the description as to what the managed configuration does. Here's another example for another schema, one with an app that has multiple VPN connection options, with each VPN server configuration in a bundle, and the bundles grouped together in a bundle array. And this is the lifecycle of how you get key value pairs on the device. Your app should check for the current managed configuration key value pairs at the following times. So when the app starts or resumes, it's on start and on resume methods. and when the app is notified of a configuration change. So you'll want to dynamically register a broadcast receiver so you can change the app's behavior when the configuration settings are changed. A few additional things to note on the points I just mentioned. Your app is not automatically notified when other apps change your app's configuration settings. To set managed configurations, set application restrictions is called, and is only visible to the target app. And to find the current configuration settings, your app uses a restriction manager's object. This is an example of how you call get application restrictions. And for those of you who would like to test managed configurations, we have some demo devices set up with the Android management experience. For development, we recommend using TestUPC, and you could use that to test on your own. I have a link for that later in my presentation. All right, work profiles. So we've heard about these. Hopefully you know what these are by now, but I'll be going over this. So it's a dedicated managed profile which isolates and protects the work user and their data. The benefit here is, as an app developer, you get data segregation. You don't have to build this functionality into your app. There are some considerations regarding intent resolution. So IT admins determine what apps are available or exist in the managed profile. So common or system apps might not be there. The DPC also controls what intents may cross the profiles. And so it's not safe to assume that your intents won't fail. And it's recommended to call intent resolve activity before firing off intents. For example, an app that needs to set timers you would need to check that there is a valid handler for the action set timer intent. If the app cannot resolve the intent, it should take appropriate action, such as showing an error message. There are some considerations regarding file sharing. So your app may need to provide other apps with its own files, with access to its own files. So a file URI that's valid on one profile might not be valid on the other. Therefore, if you attach a file URI to an intent and the intent is handled on the other profile, the handler may not be able to access the file and your app may crash. So we recommend sharing files with content URIs instead. And this is how you would get a content URI for a specific file URI. So I'll just briefly go over AppAuth since Andy extensively covered this yesterday. I mainly wanted to just highlight that this is the recommendation for app developers looking to implement single sign-on. So just to review, AppAuth is a client SDK for communicating with OAuth 2 and OpenID Connect providers. And it uses Chrome custom tabs for the auth request. While auth could be done with WebView, it's insecure, and WebView doesn't protect the session. A host app can extract the cookies, inject JavaScript. Third-party SDKs can also create risk for you. So with custom tabs, the host app can't inspect the contents, and there's a shared cookie state across apps, so users really only have to log in once. The other thing to note here is Chrome is GMS mandatory, so it should be there on the device. All right, so lastly, I'll be going over purpose-built solutions, also known as KOSU to a lot of people. So there are actually two ways to kind of lock or pin an app to a screen. One method is using app pinning, which is intended for temporarily just pinning an app, and this is initiated by user on the using the device. And the second method would be using lock task mode. And this is the better option here because a user can't escape the app. The home and recents buttons are hidden. And lock task mode gives a more robust way for IT to manage the device and the solution. So the device owner sets the packages that can enter into lock task mode. Your app is launched, and in the initial activities on create or on start, you call is lock task permitted to verify that the package has been whitelisted by set lock task packages. This will also allow you to add task lock functionality to your app without having to maintain two versions of it. So users who want to use your app outside of lock task mode and users who want to use your app in lock task mode can install the same APK. Your activity calls start lock task to start lock task mode, and to stop lock task, your activity would actually call stop lock task. So, and that's actually done within the same activity that called start lock task. So start lock task actually requests to the system to lock the user to the current task. And as I stated before, it prevents launching or the user from launching other apps, hides the home and recents button. All right, so this is an example of how you would call start lock task in an app if it's whitelisted. And one thing to note here is that this is called during the locking activities on window focus changed method. So we recommend targeting Marshmallow or later, which includes several purpose-built features. And starting in Marshmallow, if your app is whitelisted by an EMM that's using set lock task packages, your activities can be automatically launched automatically started when the app is launched. And if your app is deployed by an EMM that makes your app a default launcher, the benefit is that your app will be launched upon reboot. So this will help mitigate a poor end user experience when a device is unintentionally reset. The activity that sets the home intent should be disabled by default though, so that users not using lock task do not accidentally set your app as their launcher. And this can be accomplished by adding this activity element for this task locking activity in your manifest. If you're creating your own DPC app, so this is for the app developers who might not be using a third-party EMM solution, there are some considerations as well. So disabling the key guard as necessary. If your single-purpose solution is meant to stay on, so for example, like a digital signage menu board or like some type of interactive kiosk, use stay on while plugged in so the device doesn't sleep. You want to set system update policies for updates to ensure that you're not disrupting the end user experience. And as stated before, as a DPC, you'll want to set your app as a default launcher. That way, you get your app launched on reboot. You'll actually hear more about one of our partners who actually built their own DPC for their purpose-built solution team later today. All right, so some resources. Basically, everything that I covered here today is on the developer pages. So if you want to, take a look at everything that I went over, I would definitely recommend checking that out. On top of that, you have Test DPC. So this is where you would go and test things such as manage profiles and directly on the device without having to utilize an EMM solution. The two last ones, Code Labs, definitely recommend taking a look at both of those. One of those is for AppAuth, and the other one is for Kosu. And yeah, that's it. So I have about 5 minutes for Q&A. Do we have any questions? One question over here. Do we have the mic? Or, okay, yeah.
Thanks. With Chrome custom tabs, you say GMS makes sure that Chrome is installed on the device, but what if Chrome is not enabled in the work profile?
Yeah, so if
For app auth?
Chrome isn't enabled in the work profile, there are other browsers that also support custom tabs, and it will default to the default browser in that case. Do we have any other questions? All right, I think.
It's just one.
Oh. Yes.
Yeah, you mentioned that Chrome should be installed on device owner mode automatically, and I have a scenario where that doesn't happen.
Mm-hmm.
Could that be because I've got a too old version of the Play library? Or?
It is a GMS certified device too, so, or you're using a GMS?
Yeah,
Okay.
it's I think it's 711 or something, and it's a Nexus 5X. So
I think it should be there.
yeah, because I have to install it manually. I don't know.
And
We
have
could
you
talk
gotten any
offline.
reports of this?
Yeah, let's talk offline. It's
Yeah, we can take a
possible
look.
that your IT admin, or is it your own device or is it a managed device?
We're an EMM provider, so it could be our code too.
Oh, okay. Oh, interesting. Yeah, that's.
Yeah, this would be good to post on the EMM community.
Okay.
That way Ian can chase it down with the team. We take a bug report and properly. Yeah,
Thank you.
These things are kind of hard to debug in real time on the stage.
Yeah. Do we have any other questions? Oh, one over here.
Hi. For the COSU use case, there are ways to avoid to have the device going to DOS or app standby mode. If I want to have my application always running on the device, I don't care about the battery for my use case.
Oh yeah.
And
So like the stay on while plugged in, you just don't want it to sleep and anything like that?
no, it's not plugged in, but I want to have always the application running.
Okay, well, if when you start lock task, it's going to just lock that app specifically to it. So if whether the app is on or off, or whether the device is on or off, it should launch directly to the app, as long as it's set as default launcher as well.